Welcome to a new series on sensory technology. The last time, we look at photoelectric sensor. We look at the different type of PE sensor we have, and their application in manufacturing environments. Today we be looking at inductive and capacitive sensor. Their application in manufacturing environment will be discussed. Stay tuned. So what is inductive sensor? Inductive sensor is an electronic device that work on the principle of electromagnetic induction. The electromagnetic field is emitted from the front end of the sensor. When a metallic object comes in close contact with the sensor, eddy current will be induced in the metallic surface of the objects. The eddy current induced will affect the oscillating circuit, and as such there will be power loss. This changes in the oscillating circuit will activate the switch and there be feedback. When the metallic object is removed, the oscillator will returns to its normal amplitude. Inductive sensor are divided into parts, which are sensor body, sensory face, the indicator light, and the cabling point. The sensory face comes in two forms, which are shielded and unshielded. The cabling point contain the two power supply cable and the two feedback cables. Again, special attention should be placed on the data sheet, because there are some sensor that comes with only one feedback cable while other comes with two. The data sheet will tells which of the cable is normally close or normally open. The cable polarities can also be gotten here. The detected objects are ferrous metals, non-ferrous metals. Examples of non-ferrous metals are copper, aluminium and brass. Inductive sensor usually detect objects in range, which is why they are called proximity sensor. But there are factors that determine this sensing. One of the major factor is the sensing object properties. For more details, the sensing distance are usually stated in the data sheets. The distance varies from one material to another. A little Google search can be of help, because different manufacturers has specific range. Let's look at typical example. The sensing distance of this sensor is 15 mm. But for non-ferrous metals, the correction factor for non-ferrous material are stated here. A simple magnetic test can be used to differentiate ferrous metals from non-ferrous metals. When a magnetic material is brought very close to this metals, the magnetic was able to attract this objects. The objects stick to the magnets. When the same step was repeated to another metal of different group, the magnet was unable to attract this metals. Now that we have been able to detect ferrous and non-ferrous metal, the correction factor for the following material can be determined as follows. For copper, the correction factor for this metal is 0.3. We will multiply it with the normal sensing distance for the sensor. The sensing distance is 4.5 mm. So if we want the sensor to be able to sensor copper metals, the sensing object should be a little bit closer to the sensor. And in this case, the length between the sensor and the sensing objects is 4.5 mm. The same calculation can be repeated for the other sensor. Let's look at its application in manufacturing environments. Inductive sensor are used to sense object in a moving conveyors. It can also be used to monitor installed object. That the protect casing of a equipment. Again, this type of sensing device has its own drawback. Inductive sensor can only be used to sense metallic objects. This means they are not suitable for sensing liquids, dust and other non-metallic objects. Capacitor sensor. Capacitive sensor is an electronic device that is used to detect any object. The installed objects are regardless of the material compositions. For example, liquids, woods, metals, paper, etc. The sensing objects must have a dielectric constant of 1.2 or more. The sensing range of this sensor is from 3 mm to 15 mm. This depends on the dielectric strength of the sensing materials. Capacitive sensor has two plates that is located at the front of the sensor. This plates forms a capacitor circuit at the tip of the sensor. When the sensing object is in range, the capacitance of the two plates will increase. The increase in capacitance will affect the oscillating frequency of the sensor. The oscillating frequency is usually used to activate the sensor feedback. The activated contact can be in normally close configuration or normally open configurations. Again, the datasheet can be used to determine the polarities of the cable. The contact configuration of the cable can also be gotten. Let's do a quick recap. We look at inductive sensors. The application of inductive sensor in manufacturing environment was discussed. A simple experiment was carried out on how magnet can be used to detect ferrous metals and non-ferrous metals. We ended off looking at capacitive sensors and its application in a manufacturing environments. In the coming series, we will be looking at limit switch, the application of limit switch, and a practical examples will be demonstrated. Hope you have learned something today. See you in the next series.